Hello, this is pre-calculus note-taking for the worksheet Algebra 0.13, and the topic is adding and subtracting rational fractions. So for these notes today, I know they're review. I'm just going to go through a set of 3 examples, and from there, pretty much all the other problems are going to be the same. So example 1 is 3 over 4 plus 3n over 5n squared. Adding and subtracting rational fractions uses all the math that we've been doing to reduce and factor fractions. It uses the same exact math, but the purpose is to put the two terms together. So just like you would when you're reducing, the first thing you want to do when working with rational fractions is you want to factor all of the denominators completely. That's step 1. Factor all the denominators completely. These denominators are monomials, so we prime factor monomials. So I have 3 over 2 times 2 plus 3n over 5 times n. Once you've factored all the denominators completely, your second step is to multiply by the missing factors over themselves. And the purpose of this is we want matching denominators. So the reason this is legal is that when you multiply by, for example, 3 over 3, you're really just multiplying by a 1. So you're not changing the value of the expression, you're just changing its form. So this fraction does not have a 5 or any n's. So I'm going to multiply by 5 over 5 and then 2 of the n's. This fraction doesn't have the pair of 2's, so I'm going to multiply by 2 over 2 and 2 over 2 again. So now both of the bottoms have a 5, a 2, and 2 n's. The third step in adding rational fractions, now that you have a matching denominator, you're going to add or subtract the tops over one denominator. So multiplying this together, I have 15n squared plus 3 times 4 is 12, so 12n, those are the tops, over 1 bottom, which is 225nn. Now, I don't multiply the bottom together because we might get something new out of the top that needs to be canceled. So it's much easier if you leave it factored, and that way later on you can divide out anything that is possible. So this is the hardest step for people to remember is step 4. You're going to refactor the top. Why? Because we have a completely new expression that we didn't have when we started. This is a binomial. So when you have a binomial, you multiply, first you divide out what you need and then look to see if you can factor what's left. So I can take a 3 out of both of these, and I can take an n out of both of them. That leaves me with 5n plus 4. And this is over 225n. 5n plus 4 does not factor anymore, so we are done. So you refactor the top. Step 5 is simplify. So let's see, I can divide an n, and that's pretty much it. So what you do next is you remultiply the monomials, but leave everything else in factored form. So I have a 3 in front, followed by 5n plus 4, all over 4 times 5n, which is 20n. That is our answer. Now, we're not going to be doing excluded values at this point, but if you were looking for excluded values, just as a side note, for excluded values, you have to look in 3 places. I'm going to use a highlighter now. You would have to look for excluded values here, here, notice it's factored, and then here. You'd have to factor that and see what's left. Anything that makes a 0 in those 3 positions is excluded. Well, in all 3 cases, or actually this case, not that one, yes, this one, if n is 0, you have a problem. It's undefined. So that's just a quickie side note. All right, let's go on to another example. We're going to do p plus 2 over 2p minus 4 plus p minus 2 over 2p. So first thing we're going to do is factor the denominators completely. Again, this is a binomial. This is a monomial. For a binomial, divide out what you can and then see if it factors. So I can divide out a 2, and I'm left with p minus 2. P minus 2 is not a squared minus b squared, so we're done. On the right one, 2p is a monomial. We prime factor. 2 times a p. Okay, so we've factored the denominators. Now we're going to multiply by the missing factors over themselves. So this denominator has a 2. It needs a monomial p. So I'm going to multiply by p, put the top in parentheses. The second one has a 2 and a p. It doesn't have a p minus 2. So we're going to multiply by p minus 2 over itself. Again, use your parentheses. Now that both of the denominators match, we're ready for step 3, which is to add or subtract the tops over one denominator. I'm going to go ahead and distribute and do a little simplifying in the same step. So distributing that p, I get p squared plus 2p plus, okay, now I'm going to multiply these together. I get p squared minus 4p plus 4 all over one denominator. So 2 times p minus 2. All right, I'm going to continue simplifying. P squared plus p squared is 2p squared. 2p minus 4p is negative 2p plus 4. Now, for a second here, I'm not going to rewrite the bottom. I'm just going to work on the top, and then I'll put the bottom back. We now have a new top, so we're ready for that step of refactoring the top. I can divide a 2 out. That gives me p squared minus p plus 2. And this does not factor any further. So we're done with the top. Okay, that was fast. Over 2 times p minus 2. So we've refactored the top. I now can divide a 2 out of both the top and the bottom, and I'm going to simplify. I get p squared minus p plus 2 all over p minus 2. That is our final answer. All right, so let's do excluded values. Remember, there's 3 places you look. You look at the factored denominator of the first, the factored denominator of the second, and anything that is created at the end that is also factored. And I need to put that p in there. There we go. Okay, so looking at this one, if I set 2 times p minus 2 equal to 0 and I solve it, the 2 won't give me anything, but the p minus 2 tells me p can't be 2. That's one. Let's do the next one. Set the bottom equal to 0, so 2p equals 0. That means p is 0. That's another excluded value. And then looking at their combination here, p I already have, p is 0, and I already have a positive 2. So the only two excluded, this didn't add anything new, so the only excluded values are p can't be equal to 2 or 0. Those are your excluded values. Okay, let's do a third example. And again, I'm not going to do a ton of these because you had this in Algebra 2, so hopefully this is all review. Okay, we are going to do 2 minus 2n over 10n cubed plus 60n squared plus 80n. All right, so what to do with a negative? Let's make this interesting. Let's say that this is 2n minus 1. We're going to just change that really quick. The misunderstanding is that that negative only applies to the 2n, when in actuality, if you have a subtraction symbol or a negative in front of a fraction, it actually gets distributed through the entire top. So one of the things you can do to help avoid errors is to go ahead and distribute it and then change it with, put a placeholder plus in there. So when I distribute, I get negative 2n plus 1 all over 10n cubed plus 60n squared plus 80n. So it actually got distributed, and now we just have a placeholder. I highly recommend you do that on the very first step, which is distribute the negative. Just get it out of there. Okay, so now we're going to factor. Obviously, this is a 1, so the only denominator is going to be this one. What can I divide out? Well, I can take a 10 out of all of those. So let me rewrite this. Negative 2n plus 1 over 10, and I can take an n out. That leaves me with n squared plus 6n plus 8. That's 80n, 60n squared, 10n cubed. That does actually factor. We have a 10 and an n into n plus 4 times n plus 2. So the denominators are factored completely, so I'm going to need to multiply the first one by that whole denominator over itself. So I'm going to multiply by 10 n plus 4 n plus 2 over itself, 10 n plus 4 n plus 2. A lot to squeeze in there. Now that they have a common denominator, you're going to add or subtract the tops over one denominator. So I'm going to do a little simplifying here. 2 times 10 is 20n. So I have a 20n times n plus 4 times n plus 2 plus a negative 2n plus 1 all over one denominator. 10 times n plus 4, n plus 2. Now, sometimes people get wild and crazy and they want to start to divide out these factors. The problem is with this plus, this whole thing is one big ugly expression, and you can't cancel pieces of it. It's an all or nothing thing. All right, I'm going to work on simplifying the top. You can distribute the 20n, but only through the first parentheses. You can't do it twice, any more than if you took the number 3 times 2 times 5. You wouldn't go 3 times 2 and then 3 times 5. No, you wouldn't. You would multiply those two, get something, and multiply by the 5. This is the same thing. You have three things multiplied together. So I'm going to distribute this first. 20n times n is 20n squared plus 20n times 4. That's 80n. Let me multiply that by an n plus 2. Go ahead and simplify this. Positive times a negative is a negative, so minus 2n plus 1. Now we're going to multiply. 20n squared times n is 20n cubed, plus 20n squared times 2 is 40n squared. Now this one, 80n times n is 80n squared. 80n times 2 is 160n. Then we have minus 2n plus 1. Like before, I'm just going to work on the top, not worry too much about the bottom. So 20n cubed. Put your n squareds together. 80 plus 40 is 120. N squared. 160 minus 2n is 158n plus 1. This is a quadnomial, but I can guarantee it's not going to work out because the 158 is not a multiple of 20. It's not a multiple of 120. They have nothing in common. So that big ugly top is pretty much done. And the bottom, we just put the monomials together. You have a 10n times n plus 4 times n plus 2. There are going to be times when you can't factor anymore. You just have to stop. In this case, you would try factor by grouping, but you would find it didn't work, so you're all done. Okay, so if we were looking for excluded values, remember you look 3 places. You look at the denominator of the first fraction when it's factored, the denominator of the second fraction when it's factored, and the denominator of whatever you have at the end. So those are your 3 places that you're going to look for excluded values. Obviously 1 doesn't have an n in it, so there are no excluded values. But we can take this one, which is 10 times n plus 4, n plus 2. We can set it equal to 0 and try to find any excluded values of n. So each of these gets set equal to 0. So 10 equals 0, n equals 0, n plus 4 equals 0, n plus 2 equals 0. 10 is not equal to 0, so no solution. There are no excluded values there. N equals 0 is our first excluded value. Subtract 4, you get n is negative 4. Subtract 2, you get n is a negative 2. So those are the 3 values that you got off of the original denominator. Well, when we were done, the original denominator was identical. So these are the only excluded values we have. So n cannot be equal to the set containing 0, negative 4, and negative 2. Those are your 3 excluded values. On a last note before we wrap it up, a lot of times people confuse adding and subtracting fractions with solving, and they try to cancel out the denominators. The only way you can cancel out a denominator is if you have an equal sign. That's because the way you cancel out denominators is by multiplying both sides of the equal sign by the same number. That's why it's legal. Well, this doesn't have an equal sign, so you can't multiply 2 sides of an equation to eliminate it. This is just an expression. It's not an equation. Canceling out denominators can only be done with equations, not expressions. So if there's no equal sign, there's no canceling out denominators. Now, you can divide out individual terms in the fraction, but that's not the same as canceling denominators. So I wanted to throw that out in case it was a temptation. That is everything. Have a great afternoon.